So this video will look at the derivative of functions where the terms are in the form ax to the power of n. The derivative of that, we multiply by the power and we subtract 1 from the power. So the derivative of this first function is 5 times 3x to the power of 4 minus 3 over 2 x squared. So there's no real tricks to that first one. In the second one, there are a couple of tricks. The first trick centers around the first term, and that requires us to write that in index notation. The second term also requires some work because it's not in the form ax to the power of n. But what we can do is split the fraction, and it becomes 3x squared over x squared plus 2x over x squared. And that plus is something to be very careful of, but it's because we are subtracting a negative. The other sorts of tricks that may come up in these sorts of questions, you might be required to expand a set of brackets, for example. It's always worth looking for whether or not there are ways to simplify an expression. Now, unlike the first one, where it was y equals, this time it's f of x equals. And so I'm going to use the notation f dashed x. Please be careful with setting out, right? This is still the original function, so we don't call it the derivative at this stage. It's not until we start differentiating that we need to include the new notation. And we're not going to actually do that just yet. We are still working on this original function. Nothing with the first term. This second term becomes 3, and this term becomes 2 over x. And 2 over x needs to be written with a positive power. And 2 over x needs to be written in the form ax to the power of n if we are to differentiate. Now we call it the derivative, and that's 5/3 times 3x to the power of 2/3. The derivative of any constant is 0, which makes sense because if we look at the graph of a constant, its gradient is 0. And so it makes sense that the derivative of a constant is 0. And this last term we apply in exactly the same way. We multiply by the power and subtract 1.